Right now, the Gulf of Mexico is holding pockets of water above 30 degrees Celsius. Right now, the Western Pacific keeps loading heat under storms near crowded coastlines. Right now, the Atlantic can turn a weak swirl into a major hurricane in a single day. Right now, scientists are asking whether 157 miles per hour is no longer a big enough warning. If you count on clear storm reporting that does not waste your time, stay close and subscribe, because this story may shape the next life or death update. No guessing, no dramatizing, just facts, science, and real stakes. 157 miles per hour is where the official hurricane scale stops, not where nature stops. That is the first thing most people do not realize when they hear the phrase Category 6. There is no official Category 6 today. There is only a growing fear that Category 5 has become too open-ended to warn people clearly enough. 5 storms between 1980 and 2021 were strong enough to cross a proposed Category 6 line. That line would begin at 192 miles per hour. All 5 happened in the last 9 years of that record. That pattern is why this debate moved from a side note in science circles into public warning talk. 2 climate scientists pushed the idea into the open in 2024. Michael Weiner and James Cosson argued that the top of the current scale may now hide real differences in danger. A storm at 160 miles per hour and one at 210 are both called Category 5. To a viewer at home, those labels can sound nearly the same when they are not. 90% of the problem is not about naming a new box on a chart. It is about how fast ocean heat is changing the upper end of storm behavior. It is about whether our warning language is staying honest as the strongest storms pull farther away from old expectations. And it is about what that means for people living near water, glass, power lines, bridges, and hospitals. 27 degrees Celsius is the rough ocean temperature hurricanes need to feed and keep growing. NOAA says that warmth usually has to reach down around 46 to 50 meters. Think of that like a giant invisible battery under the storm, not just a warm skin on top. If only the surface is hot, a storm can stir colder water upward and slow itself down. 35 miles per hour in 24 hours is NOAA's line for rapid intensification. That means a storm can wake up as a nuisance and go to bed as a neighborhood breaker. It is the weather version of a small fire finding a gas line. Everything that felt manageable at breakfast can be unrecognizable by dinner. 872 millibars was the pressure measured for Hurricane Patricia at peak strength in 2015. Lower pressure means the storm is more tightly wound and able to pull air inward faster. You can picture it like air rushing down a steep hill toward the center. The deeper that pressure hole gets, the harder the atmosphere tries to fill it. 400 times the world's electrical generating capacity is about how much energy cloud and rain formation inside one hurricane can release. That number sounds absurd because hurricanes are absurd. They are heat engines pulling warm, wet air upward and turning ocean warmth into motion. The sea gives them fuel, and the sky gives them room to build. 300 miles from the equator is another quiet rule that matters. Storms need enough of Earth's spin to start twisting into that tight, rotating shape. Too close to the equator, the spin effect is too weak. Farther away, if the water is hot and upper winds stay calm, the machine can assemble itself. 23 miles per hour is roughly the upper limit NOAA gives for vertical wind shear if a storm wants to organize well. Wind shear means winds changing speed or direction with height. Too much shear tips the storm and tears its thunderstorms away from its center. Too little shear lets the engine stand upright and keep inhaling fuel. 192 miles per hour is the proposed threshold that raises the whole question. It marks the point where some scientists think the public needs a clearer signal that the storm is beyond the old top box. That debate matters because the jump from strong to unthinkable is usually what breaks human planning. By the time a storm feels historic, people are already moving too late. 50% higher risk near the Philippines and double the risk in the Gulf of Mexico under about 2 degrees Celsius of warming. That is what the modeling tied to the Category 6 debate pointed toward. Not certainty on a calendar day, but a sharp shift in the odds at the violent edge of the curve. The highest modeled risk sat over Southeast Asia, the Philippines, and the Gulf. 2015 gave the world a storm that sounded like a measurement error. Hurricane Patricia roared to 215 miles per hour in the eastern Pacific off Mexico. Its central pressure crashed to 872 millibars, the lowest on record in the Western Hemisphere. That is not a typo, and it is not an internet exaggeration. 105 knots of strengthening in 24 hours is how Patricia stunned forecasters. That beat even Hurricane Wilma's famous burst in 2005. Over 2 days, Patricia gained nearly 150 knots. A storm does not just become dangerous in a jump like that, it becomes hard to mentally track. 75 knots to 180 knots in one day is the part that should make every coast pay attention. People imagine disaster as something that marches toward them with lots of warning. Rapid intensification can act more like a trap door. You are still using yesterday's picture while the storm is already living in tomorrow's body. 130 nautical miles southwest of Manzanillo was where Patricia reached peak strength. It did not stay over open water forever and spin harmlessly for scientists. It drove toward a populated coast. That is another reason this topic matters. The most violent physics do not happen in empty textbooks. 2019 brought Hurricane Dorian to the Bahamas with 185-mile-per-hour winds. It hit Elbow Key with a minimum central pressure of 910 millibars. Then it crawled over Grand Bahama and sat there like a drill bit over the same wound. Powerful storms are awful. Powerful slow storms can be worse. 6 hours is how long Dorian's eye took to cross Grand Bahama after landfall near South Riding Point. By the time it exited, winds had eased from 155 knots to 140. That sounds like relief until you remember the island was still under a top-tier monster the whole time. When motion stops, damage piles in one place instead of spreading out. 90% of tropical cyclone deaths come from water, not wind, according to NOAA's warning language. About half of those fatalities are from storm surge alone. That is the opposite of what the public eye tends to focus on. People watch roofs fly on television, while water quietly becomes the more efficient killer. 12 feet of water does not care whether your storm is called Category 4, 5, or 6. It only cares about wind pushing seawater inland, local shape of the coast, and how long the push lasts. That is why some scientists warn that a new category might help attention, but still miss the full danger picture. A bigger number can clarify wind risk while still hiding the deadlier water story. 2013 in the Philippines gave another example of what the scale cannot fully hold. Typhoon Haiyan reached 195 miles per hour and was described by NOAA as one of the largest and strongest ever recorded. Typhoon and hurricane are the same kind of storm in different ocean basins. The name changes with geography. The physics do not. 1,000 miles across is how large these systems can get. That means the worst part of a storm is never the whole storm. Even areas far from the eye can lose roads, power, and hospital access. That wide reach is why any debate about the top category has to include size, speed, rainfall, and surge. 2013 also showed how category talk fails once shoreline shape and seawater push line up. Haiyan did not need a new label to erase whole blocks. It needed landfall at the wrong angle, violent surge, and communities with little room to absorb the hit. That is how storms turn from weather into national trauma. 30 miles inland can still become part of a coastal disaster when ports close, roads fail, and fuel stops moving. After major storms, the map of harm widens in rings. The coast takes the first blow, but hospitals, warehouses, and food routes can spread the emergency far beyond the beach. That is another reason the strongest storms cannot be judged by shoreline wind alone. 2 or 3 degrees of extra surface warmth does not sound cinematic, but warm water stacked deep under a storm changes the whole fight. It lets the system keep feeding even after its own winds churn the sea. That is one reason rapid intensification keeps showing up in almost every serious hurricane conversation now. 185, 195, 215. Those numbers are not just brag marks on a weather chart. They are 3 different hints that the old top box has become crowded with very different monsters. Which of those regions scares you most right now, and why? Tell me in the comments below. 80 degrees Fahrenheit is the old simple rule many people learned in school. Warm ocean water at or above that level can help build a tropical cyclone. But the real story is not one magic number. It is how much warm water sits below the surface and how deeply a storm can tap it. 150 feet of warm depth matters because hurricanes churn the sea as they pass. If cooler water sits just below the top layer, the storm can mix it upward and weaken itself. If deep warmth is waiting underneath, the storm can keep drinking even while it stirs the ocean. That is why some regions become launch pads for explosive strengthening. One storm can even cool the ocean behind it by hauling heat upward and away. NASA and NOAA both show this in satellite views after major systems pass. The sea looks bruised in their wake because energy got ripped out and fed into the storm. That cooling trail tells you just how much fuel was burned in a short time. 1960s satellite coverage is another reason this whole debate comes with caution. Our global storm records before the satellite era were much weaker. Some scientists stress that we should be humble about comparing modern counts with older decades. The strongest conclusion is not that every year is worse, but that the upper tail is demanding closer watch. 74 miles per hour is all it takes for a system to be called a hurricane. That starting line matters because every giant storm begins below it. No storm is born as a legend. It has to organize, tighten, deepen, and survive the conditions trying to tear it apart. 5 categories were meant to estimate wind damage, not to summarize every threat in one clean word. NOAA says the current scale does not account for rainfall flooding, storm surge, or tornadoes. That is an important pushback against the viral chatter. A Category 6 label would not magically fix evacuation mistakes or weak flood planning. 30 seconds of one TV graphic can still shape millions of decisions. That is why messaging matters so much. If the public hears Category 5 often enough, they may stop feeling the difference between extreme and absurdly extreme. Language can wear out even while danger keeps climbing. 2023 showed that rapid intensification is not some old case study trapped in textbooks. Storms like Otis stunned people by exploding in strength close to land. You do not need every future storm to break world records for this issue to matter. You only need one city to run out of time. 24 hours is a useful clock for meteorologists, but families live in smaller clocks. School pickup time, shift change, pharmacy hours, the bridge before traffic locks. That is why storms that gain 35 miles per hour in a day can feel even faster than that. They collide with the tiny schedules that hold normal life together. 900 words into this story is where I want to pause and ask something personal. What is one thing in your home you would grab first if a storm warning like this reached your street tonight? Tell me in the comments below. Most people answer with an object, but the harder answer is usually a person, a pet, or a piece of time. And time is the part fast storms steal first. 31 years separated Hurricane Andrew and Hurricane Patricia. In that span, forecasting improved, satellites sharpened, and ocean heat kept climbing. Yet the emotional pattern stayed the same. People still tend to imagine the last famous storm, while the next one is building a new standard. 1992 taught South Florida what compact violence can do. 2015 showed the Eastern Pacific could produce something even more extreme in pure wind speed. 2019 showed that motion can matter almost as much as strength. Different storms expose different blind spots, which is exactly why one label can fail. 10 miles of wobble can shift the worst eye wall from one town to the next. 20 miles of coastline shape can change how high water stacks up. A few hours of slower forward motion can turn serious flooding into a historic one. People hear single numbers because they are easy, but hurricanes punish with combinations. 50 miles from shore is not far when a storm is feeding on deep, warm water. 100 miles is not far when outer bands are already throwing tornadoes and flooding rain. The eye is only part of the threat map. By the time the center arrives, many of the bad choices have already been made. 2 degrees Celsius of global warming sounds small when you hear it in ordinary life. It sounds like adjusting a thermostat before bed. But on a planetary system, that is a huge energy shift. It changes moisture, ocean heat, and the odds of the most violent storms in ways coasts can feel. One open-ended top category also changes human psychology. When every disaster above 157 miles per hour is filed in the same drawer, attention gets flattened. A 160 storm and a 210 storm do not deserve the same emotional shorthand. That was the core point behind the proposed Category 6 argument. 2 scientists raised that point, but even they were careful. They did not say a 6th category would solve warning problems by itself. James Cosson noted that storm surge and inland flooding also need better communication. In other words, the scale may need help, but the scale is not the whole story. 49% of tropical cyclone deaths from 1963 to 2012 were tied to storm surge in NOAA explainers. That is one of the clearest opposite views to the big wind headline. If viewers obsess only over top wind speed, they can miss the deadlier flood map. A weaker storm taking the right path can still kill brutally with water. Hundreds of thousands of hypothetical hurricanes are what NOAA's SLOSH system uses to map storm surge danger. That matters because emergency planners are not guessing from one famous old storm. They test countless paths, sizes, and speeds to see where water could stack up and move inland. Those maps can be more useful to survival than the category number alone. One reason some forecasters resist a Category 6 label is simple. They worry people inland would hear not a 6 and relax, even if flood rain and tornado risk were climbing. That is a fair warning. A cleaner headline can still create confusion if the audience thinks only the top number matters. Two storms with the same top wind can carry very different danger footprints. One may be compact and fast, another may be broad, wet, and slow. If you only watch the badge, you miss the width of the wind field and the length of time the water keeps piling up. 160 knots at landfall for Dorian is the kind of number that sticks in memory. But the real horror was not just the peak, it was the stalled pace over the Bahamas, the repeated battering, the long exposure. Strength tells you how hard the hammer hits. Speed tells you how many times. 195 miles per hour is the public number most people remember from Haiyan. Whether people remember a pressure value or not, they remember the result. Whole communities can lose not only buildings, but roads, signals, clean water, and contact with the outside world. Once systems fail together, rescue gets slower and more dangerous. 157, 192, 215. Those are not just thresholds. They are a warning that the distance between our labels and the atmosphere may be widening. Have you ever felt a quake, a storm, or a flood before the news reached you? And what did your body notice first? Tell me in the comments below. 30 to 60 miles across is a common size range for a hurricane eye, though every storm is different. The eye can look calm, bright, almost fake in satellite shots. That false calm tricks people who only think locally. Just outside it is the eye wall, where the worst winds and some of the most violent changes happen. One eye wall replacement cycle can make a storm weaken, widen, then re-strengthen. That is another reason storms do not behave like simple machines. A forecast track without intensity detail can create false comfort. People hear that the top wind dropped and miss that the danger area may have grown. 20 inches of rain is a different emergency from 20 feet of surge, but both can arrive from the same storm. One traps you where you are. The other chases you inland. One can destroy from above and uphill. The other invades from the coast and bay. This is why scientists keep pushing against one number doing too much work. 2017, 2022, 2024. Recent years have kept reminding the public that warm water and crowded coastlines make a brutal mix. Not every basin behaves the same way every season, but enough high-end surprises have piled up that the old comfort language feels thinner than it used to. One forecast cone also gets misunderstood all the time. People think the danger lives only inside that narrow shape. In reality, impacts spread far outside it. A storm can weaken before landfall and still flood, surge, and isolate areas that never sat under the center line. One more hard truth sits under every model discussion. Coastal populations have grown, roads are crowded, and many communities depend on fragile power and delivery systems. So even if storm physics stayed the same, exposure would still rise. When stronger storms meet bigger human targets, the risk multiplies. 3 layers of uncertainty travel with every forecast: track, intensity, and impact. People usually hear the first layer most clearly, but the second and third layers are where lives swing, because a small intensity error near land can flip the whole impact picture. That is why emergency managers sometimes sound urgent before the storm even looks dramatic on your screen. 70% of the total runtime for most weak competitor videos is where they start coasting. This is where the real story should actually tighten. Because once you understand the machine, every new number becomes more alarming, not less. Patricia, Dorian, and Haiyan were not random freaks. They were warnings from 3 different angles. 215 miles per hour from Patricia showed how high pure wind can climb. 185 miles per hour from Dorian showed how a storm below that proposed line can still become catastrophic. 195 miles per hour from Haiyan showed that the Western Pacific can produce violence beyond what many Atlantic viewers picture. Put them together, and the ceiling starts to look less like a ceiling. 95 millibars was Patricia's pressure drop over one 24-hour period before peak. That kind of collapse inside the core is terrifying because it announces a storm finding perfect fuel. Forecasters can see it, but people on the ground still have to make choices under normal human delay. By the time the warning language catches up, roads may already be filling. 6 hours over Grand Bahama was enough for Dorian to carve itself into global memory. Now imagine a future storm with even warmer nearby waters and similarly slow movement. That is the nightmare scientists study. Not just stronger winds, but stronger winds plus longer punishment, plus more people living in harm's way. 50 meters of warm water depth, 35 miles per hour in 24 hours. 157 miles per hour for Category 5. Those are the kind of anchor numbers worth remembering, because they tell you when the ocean is loaded, when a storm is changing fast, and when the public scale has already maxed out. Once you know those anchors, headlines become easier to decode. Two kinds of honesty are needed in storm coverage. One is scientific honesty, which means admitting uncertainty where it exists. The other is moral honesty, which means not using old labels to make new extremes sound familiar. Both matter when a family is deciding whether to stay or go. 45 minutes can be the gap between organized leaving and chaotic fleeing once local panic starts. That is why late doubt is dangerous. People often think the crucial choice is made at landfall. In reality, the crucial choice is usually made while the sky still looks ordinary. 3,600 words in, let me put another question straight to you. If this kind of warning reached your neighborhood tomorrow morning, what would your very first hour look like from the moment you woke up? Walk me through it in the comments below. Would you know who to call, where to drive, what road floods first, and which person refuses to leave? Write that answer like a real timeline, because storms punish the parts we never rehearse. One free action matters before every season. Learn your exact evacuation zone and elevation. That matters because storm surge risk can change sharply over a few blocks, and guessing from memory is how people end up trapped. The map is boring until the map becomes the whole story. 2 phone numbers matter more than 10 gadgets. Pick one out of area contact and one local backup. That matters because overloaded networks and scattered family members can turn a simple check-in into a multi-hour failure. Communication plans beat fancy gear when power drops and roads close. 3 minutes is enough to change the way your home handles a warning. Turn on emergency alerts and save local weather, county emergency, and utility pages in one folder. That matters because fast storms do not wait while you search names, remember passwords, or wonder which rumor is real. Confusion eats time almost as efficiently as the storm itself. 10 minutes is enough for a dry run. Walk your exit path, your pet plan, your medicine list, and your car loading order. That matters because practice turns fear into motion, and motion is what rapid intensification tries to steal from you. A plan you only think about is not a plan yet. One more action costs nothing and saves heartache. Photograph important papers, prescriptions, and the rooms of your home, then send copies to yourself or a trusted person. That matters because after water damage or a sudden evacuation, memory becomes foggy and proof becomes valuable. Recovery starts with records long before roofs are rebuilt. 20 miles inland does not always mean safe from hurricane problems. Flooded creeks, falling trees, long power outages, and blocked fuel routes can reach well beyond the postcard beach zone. That matters because many inland families mentally opt out of hurricane season until a storm proves them wrong. Distance from surf is not the same as distance from impact. One old mistake keeps repeating after every famous storm. People prepare for the last disaster they remember instead of the next one they have not imagined yet. If their last memory was wind, they miss water. If their last memory was flooding, they miss the speed of intensification. 5 categories on paper can tempt people into false math. They imagine Category 4 plus one more step equals Category 5, and that is the end of the ladder. Nature is not a staircase with a locked top floor. It is an open system that keeps responding to heat, moisture, pressure, and chance. 192 miles per hour is not scary because it sounds dramatic. It is scary because it points to a place where the old warning language becomes less useful. That is what scientists are really monitoring, not a movie monster category, but the widening gap between hazard and communication. 215 miles per hour, 872 millibars, 105 knots in a day. Those patrician numbers say the atmosphere can still surprise experts who study storms for a living. 185 miles per hour and 910 millibars say Dorian showed how a slightly lower number can still devastate through timing and motion. 195 miles per hour says Haiyan belongs in the same warning conversation whether viewers live in Asia or not. One coastline can spend decades treating catastrophe as a rare chapter. Then one season, one angle, one tide cycle, one slow-moving eye changes local history. After that, children remember the sound of shutters, darkness, helicopters, and the smell left behind by floodwater. Storm science is not abstract once a place has a before and after. 4,500 words into this, here is the question I want left hanging in the comments. What is one thing about this story that you still feel nobody in public has answered clearly enough yet? Write it in the comments below. Maybe it is about your city, your levee, your evacuation route, your hospital, or your insurance map. Put it below, because the smartest next update usually starts with the question viewers keep carrying. 8 seconds of viral footage can make a storm look like a freak event. 8 decades of warming data tell a more serious story. The upper edge of storm behavior is being watched because it is where small shifts in background conditions can create giant changes in outcome. That does not mean panic every season. It means respect the trend without waiting for perfection. Two futures can both be true at once. We can improve forecasts, build better surge maps, and save more lives than in the past. We can also face storms whose top-end behavior keeps challenging the words we use. Progress in warning does not cancel progress in danger. 90% of fatalities tied to water, 157 miles per hour for the current top category, 192 for the proposed next one, 50% higher risk near the Philippines, and doubled risk in the Gulf under roughly 2 degrees of warming, 215 for Patricia, 185 for Dorian, 195 for Haiyan. Those are the numbers that keep this story from being just a headline. One final thing matters as much as any forecast graphic. Most people do not survive disasters because they are fearless. They survive because they take the warning seriously before their emotions fully catch up. Calm action beats late courage almost every time. One storm season never tells the whole climate story, but one storm is all it takes to alter a family tree, a town budget, or a coastline's memory. That is why low odds never mean low stakes. Risk is measured over years. Loss arrives in one night. 24 hours from now, the ocean will still be trading heat with the sky. Scientists will still be checking model runs, buoy readings, dropson data, and pressure trends. Somewhere, a coast will be hoping the map bends away. That work matters because warning people early is one of the few parts humans can still control. One community that talks honestly about risk is stronger than 1,000 doom posts. When neighbors know who needs help, who has a car, who uses oxygen, and which road floods first, the math changes. Preparedness is not paranoia, it is how ordinary people take some power back from extraordinary weather. 7 words can sum up this whole debate. The scale ends. The danger does not. That is why scientists are watching the risk of a Category 6 hurricane, even though the label is not official. And when the next big update comes, I will bring it to you straight, fast, and without the fluff.